Hey everyone! In today's video, we're going to create a procedural battle scene in Unreal Engine, so let's jump right into it. Ever dreamed of building an epic procedural landscape in Unreal Engine, with full detail, dynamic elements, and cinematic style? First things first, we'll start by setting up a third-person scene. Now go to the Plugins menu and enable both the Pcg and Landscape Patch plugins. After that, go ahead and restart the engine. Basically, the Landscape Patch plugin lets you modify terrain in a non-destructive way, meaning you don't mess up your original landscape data. It's perfect when you want to create things like roads, building platforms, smooth paths, or any custom terrain edits without permanently sculpting the main landscape. Once Unreal restarts, it's time to create a new level. Give it a name, and don't forget to save it. After creating the level, we're going to add a landscape to it. Next, we'll create a new folder and rename it to Pcg. Now let's create our first blueprint, and we'll set its type to actor. This blueprint will be used to generate our point patches. You'll see how it works in just a moment. Open the blueprint, and from the components, add a landscape circle height patch. The landscape circle height patch is a super useful tool that comes with the Landscape Patch plugin in Unreal Engine. It lets you precisely control the height of a circular area on your landscape, without permanently modifying the original terrain. If you drag your patch point into the scene and move it around, you'll notice it affects the landscape in real time. You can also tweak the radius and fall-off values to get the exact shape or effect you're going for. Now we're going to create our Pcg graph, and after that, we'll make a blueprint for our spline. But before opening the blueprint, if any of these basics feel unfamiliar, feel free to check out the first 3 episodes in the Pcg playlist on the channel. They'll walk you through everything you need to know. After opening the blueprint, go to the viewport and add a spline component. Then, in the Details panel, search for Tag, type in any tag you'd like, and hit Save. Now let's open the PCG graph. Add the Get Spline Data node, the same one we used for the first time back in episode 3. But this time, since we're working with 2 splines, make sure to set it to All World Actors mode. Then, paste the tag you assigned to the spline earlier into the tag field. As you can see, the spline data has now been assigned to the node. We can now modify the spline, and points will be generated along it in real time. Now, I want to close the spline to form a loop. Now I want to generate points inside the loop, so I'll use the spline sampler node. Then, I'll set its mode to interior. Now, using density noise and density filter, we can reduce the number of points. Now we need a new node that allows us to assign a blueprint to our points as well. After that, we'll assign the point patch to these points. The Spawn Actor node allows you to spawn any type of actor, like trees, rocks, enemies, collectibles, or custom blueprint actors, at specific points generated by your PCG graph. Now we'll assign the point patch to our node, and as you can see, it gets placed right on top of our points. Next, by adding a transform points node and tweaking the values, we can shape the result exactly the way we want. Now we want to create the path for our tunnel, so we'll start by creating a new blueprint and a new spline. In the tag field, we'll write tunnel, and then in the PCG graph, we'll link it to another Get Spline Data node. Now we can add the spline to the scene, and once it's placed inside the PCG volume, the points will appear. After that, we'll add a spline sampler node and enable the unbounded option so points can also be generated outside the volume. Now we can use transform and spawn actor nodes to create our tunnel. But instead, I want to create another point patch so I can have more control over the size of the tunnel. Now, by modifying the tunnel point, we can adjust the tunnel to our desired size. As you can see, I'm increasing the size of the landscape spline, for example, drawing a long line across the entire area so our tunnel gets generated along I. Alright, now it's time to bring the world to life. We'll add trees and rocks all across the landscape, and place some cool objects along the tunnel path too. I'll drop a link to some free models you can use, so feel free to check those out. Now we want to place beams and panels along the sides, so we'll use the same method from the previous video. To save time, I'll speed up this part of the video. For the beams, I'm using a static mesh spawner, and for the panels, I'm using a spawn spline mesh node. If you run into an issue like this while placing the panels, just make sure to rotate the mesh by 90 degrees when exporting it from your 3D software. Now we can use our point patches and bring in trees or rocks from Quixel Bridge using projection. Then, by using the difference node, the same one we used in the previous video, we can shape the scene exactly the way we want. As you can see, we can also add even more elements to the scene. As you can see, at this stage I'm using these two mountain models to cover the outer edges of the landscape. I also found a free model on CG Trader, and I'll share the download link with you below. Additionally, I've included 2 free models, a helmet and an M1 rifle, from my own collection to help you add more detail to your scene. Now I'm going to add another spline to place trees around the battlefield. You can learn this technique in detail by watching the first and second videos, but to save time in this one, I'll speed up the process again. Now, to break up the uniform look of the terrain, I'm going to create a custom landscape material. I'll be using Nanite and displacement to achieve a more detailed and realistic result. Since this tutorial is mainly focused on PCG, I won't go too deep into material creation, but you'll be able to see the process at high speed. As you can see, I'm switching the material blend mode to attribute, and by creating a landscape material with 4 layers, we're aiming to achieve the look we want. We start by importing our textures and adding a landscape coordinate node, which we connect to the UVs. Then, we create a color variation and convert it to a parameter so we can reuse it across other layers. Just don't forget to change the base color to white. We repeat the same steps for the other 3 textures and connect each of them to their respective layers. After creating the material, we make an instance of it and apply it to the landscape. Just make sure Nanite is enabled, and from there, you can control the displacement values directly through the material and its instance. And if you want to paint manually, you can simply disable the PCG graph and start painting freely in the environment.
Alright, that's it for this tutorial. If you enjoyed it, don't forget to hit that like button and drop a comment, and be sure to watch the first 3 PCG videos for all the foundational stuff.